In this video, we're going to talk about the reverse power rule and other basic integrals. Now, we know how to find the integral of a function. For example, if we wanted to find just the integral of f of x, then we know that this is just going to be the antiderivative of f of x, or in other words, capital F of x plus c. And so this is really the whole idea of finding the integral of a function. And some examples of finding the antiderivatives of functions, pretty much some basic integrals would be, for example, if we had something like the integral of the cosine of x. Really, all we're doing is we're trying to find pretty much the derivative of what results in the cosine of x. Well, we know that if we were to take the derivative of the sine of x, then that's going to result in the cosine of x. And then we just add a plus c to it. And so that's the whole idea, right? Some other examples, like the integral of the secant squared of x. Right? This one should be actually a little bit more apparent. The derivative of what results in the secant squared of x? That would just be the tangent of x, because we know if we take the derivative of tangent of x, we get secant squared of x, right? And then we just add a plus c to that. All right, just some other examples. For example, the integral of the secant of x, tangent of x dx. We know the derivative of the secant of x results in this, so we're just going to write this as the secant of x, and then just a plus c. So this right here is a whole process of finding the integral of a function. It's pretty much just the antiderivative. And so these are just some examples of basic integrals. And some other examples you might see would be like the integral of e to the x dx, right? The derivative of e to the x is e to the x, so this is also going to be just e to the x, right? And then plus c. Okay. Now there's one in particular that's really interesting. If you recall, the derivative of the natural log of x is 1 over x. So what we're going to talk about is the integral of 1 over x, right? We know that the derivative of the natural log of x is 1 over x, so we can just write the natural log of x, right? Right, and then a plus c. But there's actually something really interesting about this. It turns out what we actually have to do is we have to put absolute value there. And I'm going to make another video explaining why this is natural log of the absolute value of x instead of just the natural log of x. But this is pretty much what it is. So these are some examples of how you find, pretty much these are some basic integrals, and so you really got to know what these ones are. All right, so now we're going to talk about the reverse power rule. Now, the reverse power rule. Well, we remember from the power rule that the idea of the power rule is if you were to take the derivative of, let's just say, x to the power of n, right? We know that this is going to be n times x to the n minus 1. That means if we were to find the integral of what this is, so the integral of n times x to the n minus 1, right? We find the integral of this, then this will be x to the n, right? Because it's the antiderivative, plus c. And so we know an example of that could be something like this, like the integral of 4x cubed dx. The derivative of what results in 4x cubed? We know that would be x to the power 4. And then we just put a plus c there. So this is the whole idea of the reverse power rule. It's pretty much the power rule in reverse. So that's the integral of 4x cubed. But what if we wanted to find the integral of x to the 4th? What would this be? Well, if you think about it long enough, you'll figure out that it's going to be 1/5 x to the 5th, right? And then, of course, plus c, because if we were to use the power rule for this, right, you take the derivative of this, you will get x to the 4th. So that's the whole idea of the reverse power rule, is how do we go from here to here? And so what we're basically doing is we're taking the integral of x to the power of n, right? So what would this equal? Well, pretty much the question that we're asking is, the derivative of what, right? The derivative of what results in x to the n? So what would this be? Now it turns out this, pretty much what you would get is this would just be 1 over n plus 1 times x to the power of n plus 1. Because if you were to apply the power rule to this, you will get x to the n. And so that's the whole idea of what this is going to be equal to, right? It's pretty much, this is the whole idea of the reverse power rule. It's 1 over n plus 1 times x to the power of n plus 1. And yeah, you could write it as x to the n plus 1 divided by n plus 1, but I like to write it like this. So this right here, actually I forgot to add plus c. Right, this is the whole idea of the reverse power rule. And so yeah, that's pretty much how it works. And so for example, if we wanted to find, let's just say the integral of, so we did x to the 4th, let's just do x to the 7th. Well, in this case, our power n is 7, so we're just to say n equals 7 right here, just so we can have that in mind. If we were to apply the reverse power rule and integrate this, then what we're going to get is 1 over n plus 1, or 1 over 7 plus 1, so 7 plus 1 is just 8, so we get 8 there, times x to the power of n plus 1, or 7 plus 1, which is just 8. So we get 1/8 x to the power of 8 plus c. So this right here is how we would do that. So this right here, that's pretty much the reverse power rule. And just one more example, pretty much it could be applied to any power. So n could be any number. Like it could be like if we wanted to find the integral of the square root of x, we could figure out what this is because we know that the square root of x, this is just the integral of x to the power of 1/2. And so we could actually find what this is using the reverse power rule. I'm not actually going to do it, but as you can see, that's the whole idea of the reverse power rule, so we could actually figure out what that is now. And so actually, you know what, just one more example. All right, we're going to do one where we have a constant out in front. So, for example, the integral of, let's just say, 3x to the 7th dx. Well, applying the reverse power rule, it turns out what you can do is you can actually pull out a constant from an integral, just like from a derivative. And so you could say this is 3 times the integral of x to the 7th dx. And using the reverse power rule, you'll find that this is 3 times, right, 1 over 8, x to the power of 8. And then we just add our constant. And so we could rewrite this as 3/8 x to the power of 8 plus c. And so as you can see, this is pretty much how the reverse power rule works. That's pretty much it. So this is reverse power rule and some basic integrals that we went over. That's pretty much it.